Hello, everyone, and welcome to the first episode of Constellation Crew for the fall of 2021. Thank you all for joining us. We're going to have a great show tonight. Those of you that have watched us before have probably noticed something already, and looks like we have a couple new faces joining us, right? So, joining us today, we have Madeline. Wave to the there we go. Perfect. And we have Riley. Madeline and Riley are both graduate students here at Ball State University in the Department of Physics and Astronomy. I am as well. And my name is Greg, so it's nice to see everybody again. Nice to get started. I've missed doing Constellation Crew, so I'm really excited to get started. I'm really excited too that Madeline and Riley are joining us here at the Brown Planetarium. So we're gonna look at some cool things today. We're not gonna really take a look at any specific constellations tonight like we normally do. We're just gonna kind of take a tour of the sky. And if you notice right now, we are in Muncie, Indiana, in Stellarium, which is the program that we're using. And it is about the time now, right? So right now it's about 5 o'clock here in Muncie. And notice that, we can't really see a whole lot going on, right? Because, well, the sun's in the way, right? So what we have to do is we have to speed up time, which thankfully Stellarium does, right? So we can speed up time. Oop, I went a little too far and a little too fast. So let's back this up just a little bit. I apologize. And then we will, start to notice that as the sun goes down, right, we can see some more objects coming up in the night sky, which is awesome, right? So let's just pause it here. So this is about 7 o'clock tonight. The sun is just starting to set over in the southwest, right? Sun rises in the east, sets in the west, right? And we can already see some really bright objects in the sky right now. Right. So Riley, what are we looking at here?
Yeah, so when you look at the night sky, there's definitely a lot of things that you can observe, a lot of stars, galaxies, but we can also see planets. And so if you look towards the south, you'll be able to see one of our biggest planets. It's got the big red spot. If anyone in the Facebook chat knows which one that is, you can comment it, or if Madeline or Greg want to jump in. But it is our biggest gas giant, and it has a big red spot, and its name is Jupiter. So you can see that one there. Mm-hmm. And then if you look a little bit to its right, you can see another big planet. And that one is kind of famous for the rings that it has. And that would be Saturn. So those are two planets that you can see when the sun sets. You can look to the south. And then if you look a little bit southwest, you'll be able to see the brightest object in our night sky besides the moon, which isn't out tonight. And that is Venus. Mm-hmm. So if you guys want to go out when the sun sets and try and find those three planets, those will be what you're looking for. And the way you can differentiate them from stars is that a lot of times stars, they'll kind of twinkle in the night sky or change color, whereas planets won't. So that'll kind of be an easier way to point them out too.
So Riley, I have a question. So we said Jupiter, right, was the biggest planet, but why is Venus so much brighter?
That would be because Venus is a lot closer. It's actually the third, or the Mercury. Venus is the second planet. We're the third.
I have to do that too all the time.
I know.
Every time I have to go through, Mercury, Venus, Earth, yes, Mars. Yep. Yeah. Okay. I know which one. Yep. For sure.
So Venus is definitely a lot closer to us than Jupiter, which is why it appears so much brighter.
Yeah.
Gotcha. Yep. So then the other question I have too, right, is that Saturn, we notice, right, is way, way dimmer than Jupiter. So why is that?
Well, going in order of planets too, Jupiter is closest to us
Mercury,
before
Venus,
Saturn.
Earth, Mars.
Mercury, Venus, Earth, Mars, Jupiter.
Sure.
So that is why that one is so much bigger and brighter too, is because it is a lot closer to us than Saturn is.
Gotcha. And I bet like that, just like the scale, it's hard when we're looking at the sky to kind of like fathom how far away the planets actually are from us, because like distances even in the solar system are quite vast.
Well, like thinking about it, it's insane that we can see it with our bare eyes with how far away all these things are, and then thinking about how the stars are even further than all the planets. So
No,
kind of wild.
for sure. I think that's kind of always amazing to me, right? Is what we can see with our naked eye, and the fact that, like, you know, some of these stars are, you know, light years away, but the planets we can still see, right, because they're a lot closer, right? So the closest star to us is what?
Proxima Centauri, right?
To Earth.
Our sun.
Oh
There
wait,
we go. There
sorry,
we go.
I was.
Yep. No, I
See,
know. Yep.
I'm already thinking like outside the solar system, like
For sure. For sure.
Most astronomers do, I think.
No, absolutely, right? So that was kind of a trick question, right?
just at me right here.
Two
Right.
correct answers, depending on how you look at it.
Exactly. See? Perfect. So yeah, so the closest obviously is the sun, right? And that's why it is the brightest object in our entire sky, right? And that's why when it's up, we can't really see any other stars, right? The light just, you know, takes over from the sun, right? And just washes out everything else. But the planets, because they're closer to us than any other stars, right? And what did you say, Madeline, was the closest star outside of our solar system?
The closest star outside our solar system is Proxima Centauri. It's a couple light years away. I forget the figures because
it's like
I'm not a stellar
4.3 or
astronomer,
something.
but
Oh, see, I didn't know that, so that's awesome. I now know that Proxima Centauri is the closest star outside of our solar system, which is great, right? But the
I'm glad
planets
we-
are way, way closer to us, and so that's one of the reasons why we can see them in the night sky, right? Even with our naked eye, right? So that's amazing. But as we speed up time here in Stellarium and we start, you know, the sun gets down, we start to see this, you know, bright band in the night sky. And here in Muncie, the light pollution is a little much, right? So unfortunately, we don't get to see this. But if we take out the atmosphere and if we take out all of the light pollution, then our night sky looks like this. And you can really see this bright band. So what is this bright band, crew?
it's the Milky Way, obviously.
It's the Milky, obviously. Okay, so what is the Milky Way?
It's our home
Galaxy that we're in.
Okay, so why does it look like a band though?
because of all the gas and dust
Okay.
towards the center of our galaxy that we have to look through.
So my question is, why don't we see all of those stars like over here to the left? Right? Why is it so concentrated in this band right here?
Well, our galaxy is a spiral galaxy, so like if you looked at it like, you know, far away, it would kind of, first thing that comes to mind is a pancake. I don't know, maybe
I love
I'm
it.
just
Yes.
hungry for pancake. It looks like a pancake, but like it's got spiral arms.
For sure.
Like it's, if you looked at it sideways, it
Mhm.
has kind of more of the, you know, pancake.
No, absolutely, right? So it's that, you know, spiral galaxies are disks, right? And so this band is the band that is the Milky Way galaxy, right? It's our home galaxy, and it's kind of flat, right, like a band. So that's perfect. But when we turn on the atmosphere again, and we notice as we go up, so if we draw this imaginary line through these planets, right? So we go from Venus, as Riley had said, to what was this one, Riley? Saturn, to Jupiter, right? We can make this imaginary line, and we notice that we have these 4 stars, right? And these 4 stars form kind of a box, right? Well, and this box has a very specific name, and it's the Great Square of Pegasus. So Pegasus is what kind of animal?
Well, Pegasus,
It's a Pegasus? What is that? What's a Pegasus?
a horse
What a-
with wings.
A
Half
horse. I
horse,
wish I
half
had
human?
a horse with wings. Half horse, half yeah. No, for sure. So I always loved Pegasus, right? Because my favorite Disney movie growing up was Hercules, And don't pay attention to the fact that, I have a cat named Hercules too, right? But no. So my favorite movie growing up was Hercules, and I always thought it'd be awesome to have a winged horse, right? So we can pull up with Stellarium, we can pull up these pictures, and it shows all of these, all of the constellations that we can see in our night sky, right? Or it shows at least some of them, right? And Pegasus is this winged horse, and this box of stars is Pegasus's. Yeah.
Seems right.
Pegasus's body, right? So we have this square, the great square of Pegasus, and it is what makes up Pegasus's body. And the really cool thing is that you can find Pegasus using a different method, right? So you can draw this line through the planets, but as the night sky, or as the sun set, or as the the planets start to set, it can be a little bit more difficult to find the great square of Pegasus. So one of the other ways that we can find the square of Pegasus is to borrow another asterism, right? So what am I talking about when I say an asterism? And if anybody on Facebook knows, please feel free to put it in the chat. So what are we talking about when we talk about an asterism?
It makes me think of constellations, but they're not quite constellations.
Not quite, right? So you're absolutely on the right track, and that's amazing, right? So, and we call, an asterism part of a constellation. And perhaps the most well-known asterism, right, is the Big Dipper, right? Because the Big Dipper is not part of the Big Dipper is part of a bigger constellation. And do either of you know which constellation that is? Go ahead, Madeline. You don't have to put your hand
up. It's in Ursa Major.
Ursa Major, right? The Big Bear, right? So we can borrow the Big Dipper, right? And we can draw this imaginary line from the Big Dipper's handle all the way from the east all the way to from the east all the way to the west, and we can start to see, or south, and we can start to see the great square of Pegasus, right? So a lot of times in astronomy, we kind of borrow some of these well-known objects, or these other well-known asterisms or landmarks, right? And we can use them to find other things in the night sky, which is awesome, right? Which is really helpful, especially for those of us that aren't super familiar with the night sky, right? But just to the left,
I think that's how they used to navigate, was just by looking at the night sky.
That is, so I will say, one of the most amazing things to me, right, and one of the most impressive things is the fact that sailors used to be able to just look at the night sky and tell where they were. Like,
yeah, they were just cool.
That is a skill that I wish I had, but I don't know that I have the dedication to actually learn the night sky that well.
Yeah, they should be labeled as amateur astronomers.
Exactly. No, for sure. Yeah, it's amazing. They know more about astronomy than somebody that studies astronomy like I do, right? It's just amazing to me. But if we notice, so we're looking at the great square of Pegasus, right? And if we speed up time just a little bit, we see that there's something going on right above the great square of Pegasus, right? And it kind of looks like this little fuzzy blob, right? Oop, I gave the game away right there. Sorry. So Madeline, what are we looking at here? What is this fuzzy blob?
Very, very descriptive term right here. But it is the Andromeda galaxy. Pretty cool that there's a galaxy that we can see in the night sky if we are, well, in a place that has minimal light pollution, preferably. But does anyone know why the Andromeda is galaxy is so famous?
Because it's in the constellation Andromeda is going to be my guess.
That is why it's named. But one of the reasons
It's
why
close.
Andromeda is so famous is you guys all may have heard the name Hubble. And there was this guy named Edwin Hubble back last century, and he actually used these kinds of variable stars called Cepheids to actually discover that Andromeda was an actual separate galaxy from the Milky Way. Because before his time, people kind of thought that galaxies were just these like nebulous blobs that were like part of the galaxy, but then he was like, LOL, you guys are wrong. And so he.
Is that how he said it? LOL.
That was absolutely in the Journal of Astrophysics, right?
Oh, yes.
LOL.
Absolutely. Absolutely. Edwin was a man before his time. But yeah, so he used Cepheids in the galaxy of Andromeda to discover that there's actually a thing called an external galaxies. And now a fun other distinction about Andromeda is the fact that it is one of about 100 galaxies that are blue shifted from us. And does anyone know what blue shifted means?
Blue shifted. It looks
wavelength.
Blue.
What'd you say, Riley?
Is it the
It has to
Smurf
do with
galaxy?
the wavelength, right?
Yeah, there you go. So blue shifted basically means, without going into a lot of the nitty-gritty details, that Andromeda is actually moving towards us instead of away from us. Most things outside the Milky Way are actually moving away from us, but Andromeda is not. And so a fun consequence of Andromeda moving towards us is that eventually some number of many like billions of years from now, Andromeda is actually going to collide with the Milky Way. And I love the nickname that astronomers have actually like dubbed what the combination of the Milky Way and Andromeda is going to be. Have you guys ever heard of this nickname?
I haven't.
So
the nickname of the combination?
Yeah, they
the
actually
Milky Dromeda.
Close. I think it's Milkomeda or something like that.
Milkomeda.
Man,
and
okay, I didn't know that. Like 100%, I didn't know that, and I love the fact that I was able to get at least a little close because that's hilarious.
I was impressed. I quite impressed, Greg. Like, gold star.
You absolutely should be, right? Like, come on now.
Yeah, so that's kind of fun. Don't worry, none of us are probably gonna have to worry about like having to deal with the after effects of that because we'll probably all be dead then.
I don't know about you, but I'm definitely planning on living that long.
Millions and millions of years. I got it.
Why not?
Are you immortal?
I'm not saying that. I'm just saying I just want to live long enough to see the collision, and then I can die, right? Like, that's a life goal. You know, it's my dream.
Like, if you figure that out, let me know. I might join you on that endeavor.
Will do. So when we look at Andromeda, when we can zoom in, what are we seeing here?
So that turns out the Andromeda is actually a spiral galaxy, much like the Milky Way. And so we are looking at the actual disk of the Andromeda, and that really, really bright spot in the center is the galactic nucleus. And that's where a fun little supermassive black hole resides.
A fun little supermassive black hole. Very nice.
Maybe not fun if you enter it, but
little and supermassive.
I'm just throwing out all the paradoxes here today. Like, that's
that's great. That's awesome.
So this obviously is a very, very pretty picture that was taken by people much smarter than me and much more experienced with taking astronomical images. But me and one of my classmates in my observational astronomy class actually took a picture of the Andromeda 2 Tuesdays ago, and I would love to share it with you guys.
So what are we seeing here?
So you will notice that like the picture that are on the one side is kind of just this very like bright blob, and it's also not very colorful, and that is because due to the fact that I A, took this last week, and B, have not been able to reduce it, which is basically this kind of like astronomically fancy way to say like make it look pretty and kind of like take out blemishes, kind of like I'm doing like a little like skincare routine or something for Andromeda.
Sure.
This is a completely like raw, like off the like CCD, off the camera photo, and so that's the reason why it doesn't look as pretty as the picture we're originally looking at.
And you said you took this with the telescope here on Ball State's campus, right?
Yeah. So fun fact, if you didn't know, there are actually telescopes on the rooftop of Cooper, and they are a lot of fun to play with, and I'm learning how to do that.
Yeah, that's amazing. It's pretty amazing that here, I mean, at Ball State University, right, that we can get a picture of something as amazing as the Andromeda Galaxy, right? So,
Yeah,
so
it's
one of the
cool.
biggest differences we can see here, right, is the size of that center, right? So the size of the center looks way brighter in the picture that you took here than it does in the Stellarium's picture. So why is that?
It's probably in part to do with like just like resolving, you
Mm.
know, parts of the galaxy,
Mm-hmm.
and also because before I sent this image to you, Greg, I my battery was running low on it was running low on
Sure.
juice, and it I wanted to make sure I sent it before
Mm-hmm.
we got on the call, and just like, so I didn't take enough time to like very like, you know, make it look as pretty as you can be with a raw picture.
Sure. That's awesome though. I mean, that's better than anything I've done, right? Like that's amazing that you can get a picture of something like the Andromeda Galaxy. Like that's yeah, that's awesome. I love that.
Yeah, it was a lot of fun. I had a lot of fun that night I took that picture.
No, I bet. So before we head out today, I think Riley, you had a very special invitation to extend to our guests.
Yeah, so if you guys wanted to come out and learn more about, space and all that, we have a show tonight called Destination Mars. That starts at 6:30. And it just kind of talks about, NASA's goal to get humans to Mars. If you can't make it tonight, we also have shows tomorrow at 5 and 6:30 as well. And then if you, Destination Mars, if you want to do a different show, we also have Earth, Moon, and Sun, which is a good fun, like family favorite, that we have a show at 3:30 tomorrow. So if you guys we would love to have you come out and see those. And if you want to look for any future shows, you can also go on the Brown Planetarium website. And we hope to see you guys soon.
Yeah, gotta be there or be square, right?
Exactly. Be there or be square. I love it.